Hi guys, this is Mr. Urrego. Welcome back to our review for the Algebra 1 end of course exam. We're doing the mock computer practice exam, alright? A practice exam in the same website that the real end of course exam will be given. Alright, let's go to question number 8. If you haven't watched the first 7, please go back to our previous video so you can have the first 7 questions. Roxanne wants to test the idea that polynomials are closed under addition. Her work and explanation are shown. Drag an expression and phrases to the boxes to complete the statement. Okay, so she started, but there's a couple of blanks. First things first. When they're saying, here we go, when they're saying that polynomials are closed under addition, okay, what they mean is when we add or subtract polynomials, the result has to be a polynomial. So my answer has to be polynomial. How my answer has to be polynomial? If I get whole numbers. If my exponents are whole numbers, right? As we see here, I have a 4, 3, technically there's a 1 right there, and this is my constant. All right? So they have to be whole numbers. Right now I have x squared, cube, negative 1. Not possible, because this negative 1 is going to make this 4x goes to the denominator. Remember, when you have, I don't know, let's say x to the negative third power, and I have a negative exponent, technically, you have 1 over x cubed, right? That negative exponent brings my term to the denominator, and now this is not a polynomial function, this is a rational function. So when I have a negative exponent, that's not a polynomial. Positive cube, x squared, constant, that's fine. Negative exponent, this is going to turn into a rational function, therefore this is not a polynomial. So the only one that is a polynomial is this one. Okay, so I'm adding, let me get back over here. So if I can, hold on, where is it? Okay, this is the one. I selected, I said that here. Let me see if it's going to work out. There you go. If I add 3x to the fourth minus this polynomial added to 2x cubed, the sum is closed because, there we go, let's look. The exponents, that should be here, the exponents are, the answer is whole numbers. Alright, and by definition the sum is a polynomial. So if I add these two polynomials, my answer will give me a polynomial with whole numbers. Let's do that real quick. So x to the fourth, there's no x to the fourth here, so I'll have 3x to the fourth power. Here is 2x to the third power, so technically it's 2 to the third power, which is an 8x cubed. So this 2x is inside the parentheses. So technically, when I solve this cube, I'm going to have 8x cubed. So let's go. 3x to the fourth is this one. Negative 7 plus 8 is going to give me x cubed. And I just did this one and this one. And then I have plus 2.1x squared, plus 2.1x squared, plus 12x. And negative 9 minus 11 is negative 20. So this is a polynomial. If I add two polynomials, the answer will be a polynomial because they will have whole numbers as exponents. Right? And that's the answer for number 8. Number 9. A system of equations is shown. They give me two equations, that's why it's called a system. Click on each blank to enter the numeric value to complete the solution to the system. So what it means, I have to find the value of x and y. Okay, the first value is x, the second value is y. I gotta solve. Alright, so there's a couple of ways how to do it. We can do this by elimination or by substitution. Here, I have the x almost by itself. So let's leave the x by itself here in equation number 2. So I'm gonna have 5y, right? Oh, okay. 5y minus 6 equals x, and this 6 is cancelled. So I subtracted 6 on both sides, and now the x by itself. So I use substitution. How? I leave one of the variables by itself, and then I plug it back into the other equation. So I have 5x, but in this case, x is the same as 5y minus 6. So I'm going to write this equation, 5x minus, plus 2y equals 24. But instead of the x, I'm going to replace it by 5y minus 6. This is called substitution. And then the plus 2y equals 24. And from there, I distribute and do whatever I have to do, and then I solve for y. So let's change the color real quick. Let's get into 5 times 5y is going to give me 25y. 5 times negative 6 is negative 30 plus 2y equals 24. Combine the y's on this side, so 25 and 2 is going to give me 27. Bring down the negative 30 equals to 24. Cancel this, add 30 on both sides. And then I have 27y equals to, this is 54. Last step, divided by 27. And the y is equal to 2. As soon as I get one of the answers, I go back to any of the original and plug it back in. Alright, so I'm going to replace it here. I have 5y equals x plus 6. Like I said, I did minus 6 minus 6, so I have 5y minus 6 equals x. And now I'm going to plug this y equals to 2 here. So I have 5 times y, 2, minus 6 equals x. 5 times 2 is 10. 10 minus 6 is 4. And the x and the y. So now I have to plug it in here. You might want to double check the answers. Alright, what I'm saying is that you go back and plug it into the original. The y is 2, the x is 4. So let's do that real quick. The 5x, so it's 5 times x. 5 times 4 is 20. Plus 2y, and the y is 2, so 2 times 2 is 4. 20 plus 4 is 24, and that's right. Now the second one is 5y equals x minus 6, x plus 6. 5y is 5 times 2, which is 10, equals x, which is 4, plus 6. 10 equals 10, so those are the right answers. You want to double check every time you answers. Let's plug it in here. That's the x value. My x value is 4. And here is your y value, which is 2. 4 comma 2, and that's your answer. Let's go to number 10. Okay, number 10. They give me a table of values. Let's bring this down for a second. Okay. The function f of x models the value of goods that are imported into the United States, where x is the number of years since 1990. The function g of x models the value of goods that are exported, okay, from the United States. Okay, so imported items exported. Alright, since 1990. If f of x and g of x continue to model the importing and exporting, then sometime in 2041, which is 51 years after 1990, the two functions will be the same. Determine which function exponential. Use the table of values to justify your answer. Type your answer in the space provided. Be sure to include your function choice. Okay, so they're saying determine which function exponential. So one of these two functions are exponential. That's the whole idea. So we have two types of functions, which most likely are these two. Okay, and the one they're asking me is the exponential. So this is the form for an exponential function. There's a initial value, and this is the growth factor or decay factor, and this is time on years in this case. And this is a linear function, mx plus b, which is your y equals mx plus b. All right, so this is linear, this is an exponential. I just added a couple of values so we can identify which one is the linear, which one is an exponential. So the whole idea is the following. What I did here is I did the red side for the f of x and the blue side for the g of x. Okay, this is the slope, all right, y2 minus y1 over x2 minus x1, right, or rate of change. I applied the same formula for both columns, all right, so this is going to be y2 minus y1. the 10 million. And now I use, instead of plugging all these values because it's going to be too big, I run this. So this is going to be 10.3, 8.5, 8.8, okay? And then I use 11.8 minus 10.3, all right? And then I use the last value. I use 15.1 minus 13.4. And the x is x2 minus x1, which is 60 minus 55, which is going to be 5. And here was 50 minus 45, and 45 minus 40, which is going to be 5. If you notice, my slope was 0.36 here, 0.3 here, 0.34. So it's almost constant, okay, for being that I ran it. So this is a linear function, because the linear function, your slope is constant. It doesn't matter what points you use, your slope should be the same value. And this is approximate, constant. Now, when I check the g of x, I did the same thing, my slope. So between the first value, 8.5 and 6.3, 45 minus 40, which is 5 years, all right, I got 0.44. Then I did 11.4 minus 8.4. Or in this case, I rounded to 8.5 because it's 476. Divided by 5 years, I got 0.58. You see that it's increasing. And then I took the last two values, 20.690, which is 20.7, minus 15.3, okay, divided by 5 years, because it goes from 60 to 55. 60 minus 55 is 5 years. And my slope is 108. So if you notice, it's increasing rapidly, okay, and it's not the same slope. It's not the same rate of change, because this is increasing much faster than my g of x is going to be, which is the exported. That's, the goods that are being exported from the United States. This is going to be my exponential function. All right. So what do we write? We can write that the amount, and I'm not going to write it, but I'm going to say it. So the amount of exports will exceed the amount of imports, because the exponential function grows faster than a linear polynomial function. That'll be an example of what we have to type. Let me erase all this. That'll be an example of what we have to type here. Okay? The amount of exports will exceed the amount of imports, because exponential functions grow much faster than linear polynomial functions. All right? And that'll be my answer. Let's go to the next question, which is going to be 11. Question 11. Matthew solved the quadratic equation showing this. One of the steps that Matthew uses of the equation is shown. So this is one step, and this is the final answer. We got to complete those boxes. Drag values into the boxes to complete the step and the solution. All right. Unfortunately, when we have a quadratic, we can use the quadratic formula. But apparently Matthew didn't use the quadratic formula, because he has a parenthesis to the second power. When I have a parenthesis to the second power, this is giving me an idea that he completed the square. Okay, so from here he completed the square. Well, what is that? So let me write this down. So it's going to be 4x squared minus 24x plus 7 equals 3. So I have to complete the square, meaning I'm going to keep the x's on one side, the numbers in the other side. All right, so I'm going to keep the x's, 4x squared minus 24x. I'm going to complete the square, so I'm going to have a plus blank right here. But this 7 has to go to the other side, so I got to do minus 7, minus 7. 7 minus 7 cancels. 3 minus 7 is negative 4. And like I said, I cancel the 7, but because I'm completing the square, I need this blank. If I'm going to add something on the left side, I have to add something on the right side. All right, and now I'm going to complete the square. Before completing the square, I want to take a 4 as common factor to make my life easier. So that 4 is going to be a common factor, and between the 4x squared and the 24. So 4x squared divided by 4 is going to give me x squared. Minus 24x divided by 4 is going to give me negative 6x. All right, and I'm going to keep my blank right there, close parenthesis, and I just did a GCF. That's what I just did, a GCF of number 4. All right, now I have something inside the parenthesis. The other side stays the same, negative 4 plus blank. This blank is something that I'm going to complete. How do I complete this? So when I'm completing the square, guys, what happens is the following. There's no coefficient, there's no number in front of the x squared, there's only a 1. I need to have that. So when there's no number in front of the x squared, what I do is to find this value, I take the value of b, which in this case is -6, whatever is with the x, and I divide it by 2 and raise it to the second power. And this value will come over here. So this divided by 2 to the second, -6 divided by 2 is -3 to the second power is 9. So now that's the value of c that most people will find. If I add 9 here, I will have to add 9 in the other side. But again, this 9 is inside a parenthesis that has a 4 multiplying on the outside. So technically, I didn't add just 9. I added 9 times 4. You see? Because if this 9 will come out of my parenthesis, it will multiply this 4. Alright? So it will be 36. 4 times 9, 36. Whatever I do on one side, I do on the other side, which is 4 times 9. Now, once I complete my trinomial here, my perfect square trinomial, I'm going to factor. How's the factoring? Simple as this. That x squared comes into x, and this value will be my inside. So that x squared minus 6x plus 9 will turn into x minus 3 to the second power. And let me explain that on the side. So I have x squared minus 6x plus 9. If I want to factor this using product and sum, if you remember, I need two numbers that multiply to get 9, but when I add -6, okay, my numbers are -3 times -3. -3 times -3 gives me 9. But if I add -3 minus 3, it will give me -6. So this is the way to factor this trinomial. So my answer, that x squared, will break into x and x, and my two numbers will come over here. But if I have the same factor, which is x minus 3 times x minus 3, what I do is I do x minus 3 to the second power, because I have two of the same. And that's how I factor this trinomial into x minus 3 to the second power. Equals -4, and 4 times 9, this is 36. -4 plus 36 is going to give me positive 32. Okay? So I just made an emphasis here to show you how do I factor that trinomial. Now, remember, oh, here we go. Look at this. I just noticed. So we ended up having the step that he wanted. He has a 4 on the outside, x minus 3. Let's see how can we type this in. Oh, we can drag it. Oh, here we go. X minus 3 equals to 32 on the other side, which is 32. Here we go. And after that, we have to solve. We need to find the value of x. To solve, we just keep the process. Let's keep going on the process. I have to solve for this parenthesis, so I have to get rid of that 4. So my first step is to get a pencil. There we go. Which is divided by 4, divided by 4. This 4's will cancel. And I have x minus 3 to the second power. 32 divided by 8 is, divided by 4 is 8. And from here, I have to square root because I need to get rid of this square. So this radical will cancel the perfect square. So I have x minus 3 equals, whenever I do square root on both sides, in front of this radical, I'll have a plus and a minus. Square root of 8. Okay? And I'm getting there. I have to leave the x by itself. Plus 3 plus 3. 3's cancel, and I have 3 plus or minus square root of 8. But if you notice, the square root of 8, they have a number on the outside and a number on the inside. Because square root of 8 is the same as square root of 4 times 2. I broke the 8 into 4 and 2. How come? Because the square root of 4 is 2. Technically, I can solve square root of 4. The 2, I'm not able to solve it. So square root of 8 is the same as 2 times square root of 2. So let's complete that. 2 square root 2, and this is my final answer. Let's key that in. So I'm looking for x equals 3. Where's the 3? Here's go. 3 plus or minus 2 square root to the inside as well. And that'll be my final answer. Alright, let's go to next question. 12. The system has the solution 3, -1. F, G, H, P, Q, and R are non-zero real numbers, so there's no zeros here, any numbers. Select of the systems are also guaranteed to have the solution. Okay, so first of all, they give me a system of equations, they give me the solution, and they said, what other system has the same solution? The only way that I can get the same solution is if the system, the new system, is made out of the old system. Okay, what do I mean by that? So, I can add, subtract, multiply, or divide any of these equations by a number. Okay, and that will not change my final answer. Or I can combine them. Alright, any combination of the system, addition or subtraction, or division or multiplication by a factor, will give me the same thing. So first of all, let's look at the first one. Here I have P plus F. So P plus F, I'm adding the two equations. P plus F, and then I do Q plus G, I'm adding the two equations, equals R plus H. So I'm adding the two equations, and I labeled that my first equation. The second one is the same. So what I'm doing here in my first equation is just combine the two of them, so this is a possible answer. I'm not changing anything, I'm just combining the two of them, so it's technically the same system. Here, let's do the second one. They're doing P plus F, okay, they're adding. Oh, but they didn't do anything on the Q. But then they added my constant. No, whatever you do on one, you have to do to every single term. You see the first one, they added the coefficients for the x's, they added the coefficients for the y's, and they added the constants, which is R plus H. But the second one, they did the first one for the x's, but they didn't do it for the y's. So because of here, this is wrong. Third equation, P, Q, this is the first equation, that's fine. Let's see what happens with the second equation. 3 times P, okay, 3 times the first one, plus the second one, that's fine. 3 times the first one, 3Q, plus G, okay, that's fine. So it's 3 times the first, 3 times the first. Let's look at here, 3 times H. Oh no, hold on, the first one is R, not H. This should have an R right there, and this should be an H. Oh, that's where the trick is. So this doesn't work. That's wrong also. Next one, they use the first equation. The second equation, they're saying, all right, F minus 2P. F minus 2 of the first one. G minus 2Q. G minus 2Qs. That's fine. The last one, H minus 2R. That's fine. I'm saying the second equation is the second minus 2 times the first. Minus 2 times the first, minus 2 times. This is right. Last one, PQR. First equation again. And my second equation, I said multiply the F times 5. The G times 5, the H times 5. Yes, you're multiplying by the same number every single value. So this is an answer as well. Alright, so that's the way you can modify those equations. The only way to get the same solution is by using the same two equations. Adding, subtracting, multiply by every single term. That's the whole trick, every single term. So select, select, select. Let's go to question 13. The graph shows T, the temperature of water in degrees Celsius in a test tube after m minutes of an experiment. Okay. Drag a label to each box to correctly identify the type of rate of change. Rate of change, slope, between temperatures and times on each part of the graph. Okay. You see the boxes? Alright. So how do we call this slope? How do we call this slope? All right, horizontal line, that's an easy one. Horizontal line, that's a 0. Horizontal line is 0. What about this one? So let's go for the answers. 0, constant, quadratic, exponential. I have my 0, which is horizontal line. Quadratic exponential, guys. Quadratic, every time you have a quadratic function, we have some kind of curve. Exponential, sometime a curve like this or like that, or curve. Quadratic as well. All right, because that's the rate of change. Here is constant. Constant. Okay, so let's find that answer. Constant. Here we go. Rate of change between temperature and time on each part. Excellent. So this is a constant and this is 0. That's it. Next one. 14. The production cost C in thousands of dollars for a toy company to manufacture a ball is given by the model. This model, where X is the number of balls produced in one day, in thousands. The company wants to keep its production cost at or below 125,000. Okay. The graph shown models the situation. All right. Okay. So this is going to show me they want to keep the production cost at 125,000 or less or below. So this is the cost. This is the number of balls they do, right? X number of balls. That's right. So they want to keep this cost below this line, which is 125. Let's see what is the question. What is the reasonable constraint for the model? Oh, X values. All right, interesting. Here we go. So technically we can keep it like this. We can see both. All right. So they want to keep the cost below 125. So remember, this is cost. And at this point, it's 125,000. And they want to have it below that. They don't want this. That's a no-no. That's too much money. They want to keep it below. And now what they're saying is constraint. These are the X values. So this is where you start. You can't have anything below. Negative? No. How many negative balls do I have? No, there's no negative production. Here's 0. So this is initial value. This is how much it costs to start. Like the machines, whatever. This is initial for 0 amount of production. So the first constraint is between 0 and 262. Between 0 and 262. Okay, equal to, by the way. This is this value. All right, is below this line. The other line is below this is all this, which is between 26, 55, all the way to 32.38. Those are the values. Do we have that over here? 262, 0, 0. The only one that has a 0 is the last one. And between 26, 55, and 32, that's the answer. Here we go. Okay, so this is my final answer. Why? Because remember, just to double check, remember they want my cost over here below 125. All right, and the only time that happens is this piece of graph and this piece of graph. So for this piece of graph, you got to give me the X values, which is the first value here at 0 and the value 262. And for the second graph is 26 and 32. All right, let's go next value. And my answer is D. 15. The graph of function f models the specific humidity in the atmosphere in grams of water per kilogram of atmospheric gas versus temperature in degrees Celsius as shown. All right, 4 of its points are labeled. So this is my graph. Excellent. And it's temperature against specific humidity. And those are the units, and those are the units Celsius. All right, as we can see, this is not a linear function. Okay, this is some kind of curve. All right, so let's read what the question is. Felicia wants to model the relationship between temperature and specific humidity. Select words to complete the statement about the type of model Felicia should use. So what type of model is this? And the choices are, linear exponential. This is not linear. It's not a straight line. All right, this is a curve, so this is an exponential function. Because the specific humidity increases by equal. All right, so if it's a linear, we call equal differences. All right, common difference. But when we do an exponential, it's factors or ratios. All right, factors or ratios. Now, part B, which relationship must be true to justify the function type that models the relationship? Excellent. So, what relationship is this? So we know that we're doing exponential, we're not doing linear. So here, part A, let me get red, I guess. A, this is the slope. If you notice, this is y2 minus y1 over x2 minus x1. That's what it is. So this is the slope. No, I'm not doing linear. Look at this. Slope, right? y2 minus y1, x2 minus x1, right? 20 minus 25. When we're doing exponentials, we're doing ratios or factors. And it has to be a common ratio. And the common ratio is when we compare between the same factors. Let me explain. So the answer right now is B or D. Those are one of the two choices. So we're doing f of 25 divided by f of 20. That's a ratio. You're dividing two things. F of 25 or f of 20. F of 25 of f of 20. My increment there was from x20 to 25. Right? My increment is 5. And I use the y's. I gotta use the same ratio, the same increment in my second comparison, in my second ratio. Here, my first fractions, they compare 40 and 35. 40, f of 40 over f of 35. Again, my increment is from 5, 35 to 40. That's my increment. 20 to 25, my increment is 5. All right, same idea. Same idea. And my it's from 20 to 25 and 35 to 40. So it's 5. Let's go for the last one. Now here, f of 40 of f of, let me change the color. F of 40 over f of 20. F of 40 over f of 20. All right. F of 35 over f of 20. No, we're comparing different ratios, different increments. In the first one, we're doing 20, right? And then the second one, we're doing from 35 to 20. So here we're comparing a difference of 20. Here we're comparing a difference of 15. In order for me to have the same factors, the same ratio, they have to be the same increments, the same amount. So my answer is part B. Right, same amount, same increment from 5, and the y's belonging to those two factors. All right, so that's part B. My answer, let me select it here. My answer is B in this case. Let's go to question 16. An equation is shown. They give me an equation, quadratic. The formula, they give me the quadratic formula, can be used to solve the equation. Click on the blank to enter the numeric expression. That is one solution to the given equation. One solution. All right, keep that in mind. Now, in order for me to use the quadratic equation or formula, my function has to be equal to 0. All right, so the general formula is 8x squared plus bx plus c equal to 0. So I need a 0 on the other side of the equation. So here I got to cancel the 1. I do minus 1 on both sides. Therefore, I have 3x squared plus 7x minus 1 equals 1 minus 1, 0. From here, I'm going to label. A is whatever is in front of the x squared, which is 3. B is whatever is in front of the x, which is 7. C is my constant. All right? So those are A, B, C's. Now I have my quadratic formula. I just need to plug these values. And that's it. So let's start. Get it blue here. X equals negative B. Right? Negative B, B is 7. Plus or minus B squared. But B is 7, so I'm going to have 7 squared. Minus 4 times A times C. 4 times A, 3. times c, -1. Everything over 2 times a, which is 3. X equals -7 plus or minus 7 squared is 49. -4 times 3 times -1. 4 times 3 is 12. Negative times negative is positive, so plus 12 over 6. All right, next, -7. I can add the 49 and the 12. The 49 and the 12 is going to give me 61. So it's going to be square root of 61. All right, and divided by 6. Now the question is, click on the blank to enter the numeric expression that is one solution. They're not asking me for both. Right now, you see I have a plus or minus. So technically, I have two answers. I put two arrows because I'm going to write two answers. 1x can be -7 plus square root 61 over 6. But the other answer will be using the negative. -7 minus square root 61 over 6. And that's what they want me to type in here. So let's type that. Let's see how much it's going to change. -7. Let's see how it's going to be. So -7, -7. And I can do the plus or the minus. It doesn't matter. So it's one of the answers. Let me put the minus. The square root of 61. Okay, I got to erase this over 6. All right. Okay, I just realized that I had to put the fraction first. So in order for me to write any of this, I need a fraction. So I'm going to hit this. All right, and now I have a fraction. At the top is going to go -7. And remember, I have one answer with the plus and one answer with the minus. I erase the minus so you can see the calculator. So let's use the plus for now. -7 plus, where's the plus? Here we go. Plus square root 61. Square root. Here we go, 61. With the arrow, I'm going to go down. And at the bottom is going to be over 6. And that's one answer. So you can use this one or the negative, right? Practice using keying this in. All right? One more question so we can finish this session. Guys, remember to subscribe to the channel, please. All right, next question. Oops, I guess there's no more question. We just ended session number 1, all right, for the Algebra end of course exam practice with the computer, right? We're going to start with the session number 2, and that will be in a different video. So 16 questions, really nice. Here's where if you see something missing, then you're able to check and go back and finish. All right, guys, again, if you are learning, please subscribe to the channel, like the video. That means a lot. That is going to help me a lot to grow my channel. And also hit the notification bell so you can get the following videos. I'm going to do more videos on the Algebra 1 EOC. All right, I'll see you in the next one. Thank you for watching. Bye-bye.